Hello, hello. Okay. Mm-hmm.
No, I know, the QR code, it just doesn't work on my computer, so I just have the list, but if you guys are. Oh, okay. Thank you so much.
Let me, yeah, I'll switch. It's HM.
Do you mind if I steal your microphone first?
Yeah, yeah.
Okay, this will be quick because everything is closed anyway.
Oh.
Yeah. Okay, guys, hi. Welcome to our second AI cohort workshop. My name is Nicole. I'm the Explore PM. Before we get started, I'm just going to talk to you guys about the Explore program a bit. If you've already heard it, please just bear with me. If you haven't, please pay attention. So first thing I want to highlight, as always, is our Explore Hub. It's go.fiu.edu/Explore Hub. This is where you'll find all of the live streams and the Notion docs for these workshops. So if you missed something, you didn't really understand in class, you want to catch up, you just want to get some of the resources again, you can always go there. That also has a calendar of all of the events for the different workshops. So Explore is open to everyone at all times. You guys can attend any workshop that you want, but we're doing a cohort style. All the cohorts are closed for the semester. We're going to start back up again in fall. But again, it doesn't really matter, still open to everyone. If you guys sign up for the cohort track and you go to all 3 of the workshops and fill out my surveys, then you're gonna get your certificate of completion and your Explore merch, which are these cute little pins. So go down. Basically, it's already closed for the semester. Now keep going down. Okay. All the way down, all the way down. Yeah. No, keep going down, because it's closed, so it doesn't really matter. But again, you're free to attend any kind of workshop if you're interested, even if you're not part of that cohort. Maybe you don't know if you're interested, and then you can kind of go dip your feet in and see if you're interested for next semester. So I'm going to highlight some of our upcoming events. Tomorrow we have our last game dev workshop. We've been creating Flappy Bird, and we're going to be going into the game mode. So the first one was like the environment, the second one was the player physics, and then this is the game mode, kind of tying everything together. It's going to be at 4 p.m. in PG6 115. If you guys are interested, keep in mind that we have all this on our socials and on our Discord as well, and there's an Explore Hub channel there. So if you guys have any questions, you want any of the information that we shared during the workshop, you guys can always reach out there. And then scroll down a little bit more. On Friday, we have, I should have put Friday. On Friday, we have our Flag Ops event, which is our Capture the Flag event. It's something new that we're doing this semester. If you guys are interested in cybersecurity and you kind of want to see what it's like and you want to try to win some prizes, I think we have like over $300 worth in prizes, and we're going to have food as well. Yeah, put Friday for me, please. Yeah, thank you. If you guys don't know anything about Capture the Flag in general, don't worry, because we actually did a boot camp like 2 weeks ago. All of that is linked onto this form, which is like the sign-up form. So you guys can go take a look at the hacker guide that we made, that boot camp, and if you're interested, the deadline is today to apply. Get together with a few people and test out your skills. It's going to be Friday at 3:30 in PG5 155, so the room that's like right over there. Yeah, that's it. I'm going to hand it over to Victor now. Thank you guys.
Thank you, Nico. Let me just put it. This is always the hardest part, is putting this. Oh my god. God. Oof. Okay, perfect. Hi guys, how are you guys doing today? Happy Wednesday. So glad that you guys came here today. And today, well, as Nicole said, this is going to be our, well, technically, if you count the first workshop, this is the third workshop of the AI's Explore here. So you guys already did the check-in, right? Just to make sure. Okay. Okay. So this is just simple stuff. And before we begin today, just go a little bit over the agenda today that we have. So just to recap, so in the first workshop we did a Python review. Then in the second workshop we did a basic introduction to supervised learning, unsupervised learning, reinforcement learning, and also a little bit about data. And lastly, we also did the KNN model. So before I begin here, was anyone able to complete the challenge that I did, like to make a better model using the KNN? It's okay. No one? Okay, that's fair. But I'm also going to do another challenge today, but it's fine. Okay. But remember, oh, yes.
I tried, but I couldn't get past the 77 point something that we did in class.
Seriously? Wow.
Yeah, I like played around with the end variable and I added some of the ones that we took.
And it did not.
It was just going lower to like 74. So
Oh,
couldn't get it.
interesting. Wow. But thanks for the feedback. Yeah. Wow. But today we're going to have another challenge. And so just stay with me here, okay? So for the agenda, today we're going to do a little bit about linear regression. It's an important model and also an important topic in math to understand for machine learning in general. Then we're going to start the project so you guys can get some kind of experience in what it's like to work with more of a real data set or something like that. And then for the second half of today's workshop, we're going to do an intro to neural networks, which can be a very, I don't want to say complicated, but more of a like it takes a little bit of time to process everything because it's a lot of small details. So so this is just gonna be an intro, okay? So you guys get familiar to it. And then in the end, we're gonna try to improve our project with using neural networks, okay? Any questions, any kind of thoughts, anything before I move on? No? Okay, if that's the case, let's get started with linear regression, okay? Perfect. Okay. If you have probably taken some kind of statistics course before, maybe you are already familiar with this topic. If you are, good. If you're not that familiar, it's okay. This is a very simple thing to understand, okay? So here it is. So what exactly is linear regression? So the idea here, let's say that we have some kind of data like this, okay? And we have y and x, and these are all data points, right? What will happen if we want to try to make a line on it, on this graph, this one here? Well, if you want to try to make a line on it, it might not be perfect, but it's okay. What we are trying to do is to try to find out a linear relationship on this data. And if you were to try to fit a perfect line on this data, you would probably look something like this. Probably like this. Hold up. Yeah, probably. So, but how can this like be useful or some kind of? Well, the idea here is to try to find a certain pattern in a data, okay? In our data. So that, for example, in future data points, if we were to try to predict it, you would probably get something like here. Oops, sorry. Like here, for example. It might not be perfect, as I said, but it still could be a pretty accurate prediction. Does that make sense? If you guys have any questions, just ask me, okay? There's no right or wrong questions or anything like that, okay? Yeah. Yeah, so they could be literally anything. So for example, this could be like, let's say if you are trying to predict the price of a house, for example, and X could be like the area of the house, right? And Y would be the price. So this could be like you're trying to predict the price of a house based on the area. So let's say we build this linear relationship right here based on the data. And then if I give you some area right here, then the prediction would be something like here. So that's kind of like the idea, okay? But yeah, Y and X could be literally anything. So X would be like the features, and Y would be like our target. Remember from the last workshop? Target, features, some important concepts from the last workshop. Okay? So yeah. Now, I want to ask you guys something. Are you guys familiar with what an outlier is? What is an outlier? Can anyone tell me? Huh?
Something that goes outside of the standard deviation.
Yeah, that's perfect. So an outlier, as Miguel said here, it's basically something that goes off our data. So for example, let's say that so this is our data, right? So, and follow this pattern right here. But we have some really weird data point right here, for example. Would you guys think that this data point is like this one right here? It could be an actual data, or it could be like an error or something. Yeah, so that's basically what an outlier is. Now, it's important to keep this kind of thing in mind, because an outlier can be really, really dangerous to our model, okay? And why is that? Let's say that we have an outlier right here, right? And when we try to fit our line into our data, what do you guys think it's going to look like? Do you guys think it's going to be like the same one that we had, or it could be some deviation or something like this? So like this one, or this one? Which one is it? One, right? And you guys can see why this can be so dangerous to our model. An outlier could literally destroy our entire model. So this is why it's a very important thing to take care of first, okay? So just put it here, outlier. So again, what is linear regression? It's basically a math kind of skill, you could say that we try to find a kind of a linear relationship into our data to make a line and fit on that. Okay? Perfect. Any questions? Anything like that? Thoughts? Okay. Now, before we move on, I want to talk about a very important metric right here. It's called the R2 score, this right here. So the R2 score is basically an important metric that we use. It could be not just for our model, but like in machine learning in general, that can tell us how linear some data is. So for example, back to our data. Let's say, so this is our data right here. And if we were to try to get our R2 score, we would probably get something like 0.08, where if we have R2 being 1, this is perfect, like a perfect fit. Like all the dots, they're all here in the line. This would be like a perfect. Well, but as you can see, not every data point is on the line that we have. So that's why it's not 1, which is the maximum here, but it's something close to it, like 0.8. Okay? So if we have an R2 score of 0, what would that mean? Completely random, yeah. It has no linear relationship at all, okay? So just some really random data, okay? So again, let me put the range over here. So the R2 score, it can go from -1 to 0 to 1. So it's in between this range right here, okay? And if we have -1, it's the same thing as 1, but it's actually going down, okay? It's a linear relationship, but going down, okay, for -1, okay? Okay? Does that make sense? Any questions, okay? Anything at all? All right. Perfect. So now that we understand a little bit of what a R2 score is, now we can move on. Let me just change this. Okay. So again, so I don't wanna go too deep into the math behind it. Well, if you take a course on statistics, you're probably gonna work with all of that, but that's not what is really important here, okay, for us. What is really important is to understand these concepts, right? So right here, if we were to make a line, like in simple algebra, how do we calculate? Right here, this is the formula, right? Y equals mx, which is the slope, m, and b, and which is the y-intercept, right? And and the formula to calculate the slope, it's something like this, right? So m equals delta y. Okay? But for linear regression, since our data is not a perfect line, this is the actual formula to calculate it over here. I know it may look a little bit complex, but it's just a few numbers, like a lot of sums to do. But it's not that crazy, yeah. And this will be our B for linear regression, okay? Perfect. And how would it look like? Let me just change over here. Okay, perfect. So, but what if we have more features? Because not every time we're just working, for example, with just one feature like this, just like one feature, just on one X, and that's it. But we are probably might be working with more features, more X's, right? And essentially, it's just going to be the same thing. And this is the final formula. We just sum them like this. So we have, for example, this would be like the first feature. It's like feature 1, and this is 2 right here, and this is 3. And this is the same idea as this formula right over here. So nothing really changes, okay? Okay, perfect. Do you guys have any questions on this? No? Okay. So I'm gonna stop talking about this boring part, which not everyone likes talking about math, which is fair, but it's very important to understand, especially in this topic with machine learning and deep learning as well, okay? So now, guys, we're gonna get started with our project, okay? Which is gonna be building our electricity bill price predictor. Perfect. Okay, so I'm gonna review with you here the process of building a machine learning model, okay? Which is the same thing that we did with our KNN model from the last workshop, okay? So I really want you to keep this in mind whenever you're building a model, okay? So what is the first thing that we do? So we analyze our data, okay? We have to analyze the data that we have to understand what are the features, what we are trying to predict, and everything, right? Then, after that, we're gonna import the data to our code, okay? Then, we're gonna have to adjust our data to our model, because not every time our data is gonna be perfect. And we have to make sure that our model can understand our data, okay? Then after that, we're gonna do the training to our model, which is really one of the coolest part. Then make the predictions with testing data, okay? And at the end, we're just gonna evaluate our model to see how well it performed, okay? Any questions on this? Anything? Just let me know, okay? Now, before you guys can start getting your computers on, but before we move it to coding, I want to first talk about the data that we have here. Okay. So this is our data today that we have for today. Let me show it to you. Okay, so we have a few things to be analyzed here. We have a few columns here. We have usage, number of days, usage per day, charge, read type, average temperature, and season, okay? And since we are trying to calculate or predict the electricity bill of some house or anything, which column do you guys think is going to be our target? Which of these columns is the price, represents the price that we want to try to predict? Charge, perfect, yeah. So this is our Y column, okay? And the rest of it is going to be all features and X in our X, okay? But before we move on, what is something that you can kind of see in our data? What's something that is like interesting before we move on?
We don't really need maybe read type column.
Nice catch, yeah. So if you see the rest of all the data points, the read time is just some random column. So yeah, exactly. This is something that we can eliminate. And as I said, so this is like the raw data that someone might give it to us, some like data collection, and this is the data that we got, okay? But since we are trying to predict something, this is not going to be something important, which is the read type. And one of the things that we're going to need to do is remove this, because we don't need that. Why do we need to make more space to our program? So it doesn't make sense to have that. What else? What else is interesting in our data set here?
Winter's being the month, the season with the most amount of electricity usage.
You're saying talking about the season?
Yeah, the season.
What about it?
Winter, there's been the highest electricity bills of that season alone.
Oh, like you're saying that like in winter it's like more expensive? I didn't know that actually. I didn't analyze that. But yeah, but there is something interesting with season, with that column. What will happen if we were to try to give that column to our model? Do you guys think that our computer would understand that? Like, what they actually mean or something? Right? So the idea here is that our computer can't really work with words or strings, right? And one of the things that we're going to need to do is encode these words. So we have here the seasons, right? So we have, we have spring, we have winter, and summer. Does anyone have any idea of what we could do to make sure that our model can understand it? What could we do?
Establish a range with the average temperature.
Mm,
You can see which one is spring, winter, summer.
maybe too complicated? But there's another idea that we could do. What if, for example, yeah. Oh, you. Oh, sorry. I saw you raising your hand. Yeah. Okay. So, what could be another thing that we could do? Another important skill that we need to take advantage of here is that we could actually replace all these words with actual numbers. So for example, spring would be 1, winter would be 2, and summer would be 3. That way, our computer, our model, would be able to understand what those actually mean, okay? So for example, if this is like our data point being analyzed, it's important to know that we have winter here. So, and it will be represented as 2, okay? An actual number, okay? Now, there is one last thing that I want to talk about here. What could be another important thing to notice in our data? So we already did, I'm putting it right here, like remove columns, encode column. But what is something else that we need to do here? What do you guys notice about these numbers here? For example, let's say usage and average temperature. What do you notice? What can you tell me about these two numbers?
Maybe one, usage is just int, and average temperature is what, floating number?
I'm not really talking about data type, but I like the way you talk. Yeah?
The lower the average temperature, the higher the usage?
Not really. Yeah, I don't want you to try to think about some kind of logic here to maybe get a shortcut or something. Not exactly, okay? What I'm trying to tell you here is how far apart these numbers are. And what do I mean by that? In our linear regression, as we saw in our graph, if we have, for example, this huge number here, it could have what is called a bias. So what do we want to do here is to actually make sure that, for example, usage and average temperature, they have the same importance in our model. Does that make sense? So what is something that we can do here? We can scale our, yeah. Oh, okay, yeah. So the thing that we can do here is actually scale our data to make sure they are in the same range. So I'm gonna put here, scale data. Perfect. So these are important things that we needed to cover on our data set, okay? And now we can get started with our project, okay? Let me just change here. Desktop. So make sure you guys have your computers on, okay? You guys should have access to the Explore Hub here. You guys have that? Yeah. Okay, make sure you have that. You can just type the go.fiu.edu/Explore Hub, okay, to access this whole page. Okay, then you can go scroll down a little bit, and you can find our workshop. And then you go to cohort 2, and click on this Notion doc link, okay? Perfect. Once you're here, you can scroll down to workshop 3, and here you're gonna have access to literally everything. And the first thing that I want you to do is to click on this Google Colab here, okay, to have access to to the code, okay? Perfect. You guys see that? You guys have that in your computer? Awesome, perfect. Now, another thing that we're gonna need to do is to download our data. So here, if you click right here, you can find our data set, okay? Here. It has 120 columns, which is not too much, but you're gonna see why it's not. I didn't want to put too many data points here. And here, if you click here, you can download the data set, okay? So make sure to download that. Data.csv. And now we're gonna put it right over here. Let's see if that one. Does that work? No. Cool. Okay. So our data is here, okay? So this is like in this folder right here, okay? You click right over here and make sure to upload it right over here. Perfect. You guys good on that?
Sorry, where do you find the data?
Here, in the link in the Explorer Hub. Okay? And then you download right over here. Okay, so make sure you have the data uploaded here. Okay, so we can access it. Okay, have access to it. All right. You guys good? Is it working? You guys have that? Okay, awesome. So now I'm gonna sit down for a moment because we're gonna get into gonna start coding, right? But again, if you guys have any questions, just let me know, okay? Awesome. So here, what is the first thing that we do? We're gonna need to what? Import our data, right? And how do we do that? So these are all the libraries that are gonna help us make sure that we have our model and we can do all of the stuff with it, okay? Yeah?
We always use Python, right, with AI, I think?
What was that?
We always use Python, right?
Yeah. I mean, technically, the idea would be to use, for example, like C++ for AI and stuff like that. It'll be much faster. But yeah, but Python, it's much easier to handle, basically. But good question. Okay, so let's import our data so we can write something like this. Let me show you. So our data is going to be equal to PD. We're going to access the library pandas and the method read CSV, okay? And we're going to have to put here the path to our data. And you can just go here to our data, right-click, and copy path. And just paste over here. Okay? Awesome. Now that we have access to our data, now we have to make sure that our data is in a data frame, okay? And we can do that by writing df equals, again, we use pandas, data frame and data. Okay? We're getting our data here, our raw data here, and now we are turning into a data frame, okay? And now you can just run that. Okay? And also right here, you can also write this. You're going to use the method head so we can see our data. And this is what we get.
I have to go to class really quick. If nobody's here at 6 to help you pack up, can you send another message in the Discord?
Oh, okay, I will do. Okay.
Let me know.
Okay. Bye. Okay. So this is useful so we can take a look at our data as always, right here. Another thing that we can do is we can get our number of columns and rows if we do df.shape. And here we have 120 rows and 7 columns, basically, okay? In which 1's going to be our target and 6 are all the other features, right? Perfect. Now that this part is over, now this is the data handling pre-processing part that it might be a little bit boring, but just bear with me. Okay, so again, what is something that I told you earlier that it was really, really dangerous for our model? Outliers, perfect. And what we are doing here, well, this is just like math formulas that we do to calculate outliers to make sure that we find them, okay? Well, you're gonna see all of that if you take some statistics course, but you don't have to worry too much about this, okay? You're gonna learn all of these terms like first quantile, the third quantile, and IQR. All of these terms are all from this math course, okay? And basically here, this is like the condition to find the outlier. And once we find this, then we append to our outlier array, okay? Our list, okay? And this is the same thing to find outliers, but in the usage column, okay? This is to find outliers in the chart and outliers in the usage, okay? Okay, but the actual thing that I want you to code right now is to write the line to delete these outliers from our data. And it's actually pretty simple. It's just, again, it's all about using the methods from the library. So like, and the method that we're gonna use to remove these outliers is called drop. df.drop. And what do we want to drop? The outlier list. Now, another parameter that we need to include here is the x, which is going to be 0, because we want to remove rows and not columns, okay? If we were to remove some column, then the x would be 1, okay? And then another parameter is in place equals true, to make sure that it actually changes in our data. Yes?
Can you repeat the part with the axis?
Okay, so the access is to specify this method drop where we want to remove it. So the 0, it represents that an actual row. If it were 1, then it will be a column. Okay? So I can put it right here. Axis equals 0. Remove row. Axis. Remove column. Okay, perfect. Now that we just removed the outliers, now we're gonna remove some unnecessary columns, like the one that we pointed out earlier. Okay. So here I'm gonna create a list called removed columns, like this. Okay. And I'm gonna put it equal to, and here are the columns that I'm gonna remove it. Okay, let me just show you here again. Actually, on here, df.hat, just to show you again. And the columns that I'm actually gonna remove here are reads type, because you don't need that. And another column that I'm gonna remove here is the number of days, because at the end of the day, they don't really matter to our model, okay? So we're gonna remove these two columns, okay? And we're gonna do right over here. So what were they? Read type and number of days. Just make sure that you're writing like in the same way, because it's all case sensitive and all of that, okay? And make sure you have all the spaces as well. Capital T, capital R, capital N, capital D, okay? Just to make sure. Perfect, should be good. Okay, now we're gonna write the same thing that we did over here, but to remove the columns. And how we do that? df dot what? Drop, perfect, because we want to remove it. And we want to remove it what? This is the parameter, just to make sure. And we want to remove the remove columns list, just like this. Okay? Is it too small? Awesome. Okay, removed columns. And what is the axis now? Is it 0 or 1? 1, right? Because these are all columns. And again, in place equals true. And after that, we can also we can do later, but I'm going to just put it right here, the df dot shape, just to get the new number of rows and columns. I'm going to put something like this. New number of rows and columns. Okay. Like this. Perfect. Okay. Awesome. So now, any questions so far? You guys want me to go back at any point, just let me know, okay? Make sure it's you wall. Okay. Now, this is what, the last boring part of working with data. I'm sorry that I'm actually putting you into a lot of like this data part here, but it is actually really part of like working with machine learning.
I find it helpful because I've never used Python, so it's kind of like I'm learning.
Oh, that's great, yeah. Maybe you guys have seen the new major that FIU is offering is the data science and AI. That's why it's actually is also called data science, and not just AI. Okay, so now the last thing that we're gonna need to do is what? Is work with our, remember here, our CSM column? We can actually work with words, right? So we're gonna need to encode this into actual numbers, okay? And here's how we do that. Here, encoding the categorical features, okay? And here's the list. And here's a for loop that goes through all the data types for each column. And we just make sure that we are getting an object type, okay? That is actually a string, okay? And now we're gonna code over here the part to encode these columns. And we're actually be working with a class. I'm gonna call it, you can call it anything, but I'm call LE equals label encoder. This is a class for one of our libraries. Let me show you. Here, label encoder. It's right here. It's from the scikit-learn library. Now that we have it, now we can just create a for loop to get each column. Well, in this case, we're just working with one column, but it's a good practice to work with this way, because not every time we're gonna have just one column that is with words instead of numbers. Okay, so for categorical in categorical columns, which is the list right here, with all the columns that have words instead of numbers, and we're gonna transform it like this: df categorical, which is the column. Okay, this doesn't have, okay, just to make sure here, this could be like anything, any name that you want here, just so you guys know. This could be like column, anything. It's just to name it the column that we are working with at this point, okay? And if it were column, then this would also be column, okay? It doesn't really matter, just so you guys know. So now we're gonna access some of the methods from this class here, this object, LE, and it's called fit underscore transform, this one right here. And what do we want to transform? Our column, right? Perfect. Awesome. Do you guys have any questions on this?
Yes.
Yeah.
Turning the seasons or like converting into numbers like you said before, 1, 2, 3.
Yes.
Because I have compiled it and it puts like an automatic comment and says turning into yes or no.
Maybe only if it's a binary, because
The same exact code and it just appeared like automatically. Maybe I don't know.
if you were to like turn yes and no, it'll be just like 1 and 0, for example. Yeah. But here we have like 3 different. We have winter, spring, and summer, right? So we are making 3 different numbers here. But yeah, okay. And now, the last thing that, almost the last thing here, one of the last things here. This is actually pretty simple, but remember that in machine learning, when we're dealing with data, we're actually gonna have to split our data into a training data and a testing data. Why? Can anyone tell me why do we have to split it like this? What is the training data for? Train the machine. Perfect. And what is the testing data for?
We give the machine some data and it'll do what it's supposed to do.
Yeah, exactly. Do what it's supposed to do, which is predict. Do the predictions, right? And this is what we do to also evaluate our models. And we have to split it. And this is how we do it. We're going to create some new variables here. We have df train, which is the part for the training, df test, and we're going to use a special function called train test split, like this. And these are the parameters. So we want to split our data frame called df. And we're gonna want to make sure that our train size is 80% of the total data set. And the test size is gonna be, well, 20%. 0.2. And oh my God, I hate it. This keeps showing up. Okay. And a random state of 42, okay? This is just to make sure that every time we run our code, it doesn't create different data sets, okay? Just to keep at a constant on splitting, okay? Any questions on this? If you guys want me to go back at any point, just let me know, okay? Now, I promise you, now this is the actual last thing, okay, that we're gonna need to do to make sure that our data is perfect, okay? So we're gonna need to scale our data, okay? And I already put it here, the columns that you wanna scale, okay? And this is the class that we're gonna use. It's called min-max scaler. It's from scikit-learn as well, just to show you here. Pre-processing, yeah. These are all pre-processing you guys can see from this module to work with data. And we go back here. Awesome. And these are all the columns that we want to scale, okay? And this is how we do it. So we're gonna have to scale for both df train and the testing data. So we're gonna first do for df train. Df train is scale columns. We are updating them to be what? Now we're gonna call our object scalar, and we're gonna use the method fit transform. And again, df train scale columns like this. Okay, so here we are just updating, okay, our scale, our columns to a new scale model, okay? Scale data, okay? Now we're gonna do the same thing but for the testing data now. df test, scale data, scale column, scale columns. Now we call the object, which is scalar, and we access the method fit transform to do all the work for us. df test, scale columns. Perfect. I know this could be boring for some people, I understand. This is not much exciting, I guess. But this is really important, okay? Now we can run this whole thing and see what we get. Okay, so here, remember what was our original shape? And once we removed the outliers, we removed what? 12 outliers, I see. Okay, and here we removed 2 columns from our data set. Okay. And now we can also bring over here our data to see how it looks like now. What is wrong now? Wait, what? Oh my God. We have to run it again just to make sure. Let's see, yeah. Really annoying. Data.head. Let's see if it shows. Oh gosh. Run it. Perfect. Oof. Oops, sorry. Should be df. Df, let's do our train to see how it looks like. Gosh, it's not really updating. But yeah, it's okay. Just keep running all over again. Awesome. Okay, So you guys can see now that like our season is not like spring or summer or winter. They're all numbers. The others, it's not showing up here, but it'll be half. So this could be like summer, winter, and spring would be 0.5. Okay. And you can see now that all of our data they're all scaled into the same range now, from 0 to 1. And we have the removed columns here, and now it's all perfect now. Now, let's train our model, finally. Do the actual fun here. Let's so get our model. So our model is going to be the linear regression, right? Like this. Perfect. And now let's first get the x from our train. So our x is going to be all of our features, which is everything except for the target column, right? So it's going to be df.train and drop. We're going to use a drop. And columns. You want to make sure that it doesn't include the charge column, okay, which is the actual thing that we want to predict. And our y is going to be now df, and it's just the charge, like this. Perfect. And the last thing, well, remember in the PowerPoint that I showed you guys all the formula to calculate the line. Remember it was like a long formula and everything. Well, guess what? We don't have to worry about that. We just actually access a method called fit, and it does all the work for us. X train and y train. Perfect. Oh, and now we can run it. Awesome. You guys have any questions on this? Get feature. Get target. Okay, just so you guys know. And this is the actual training part, okay? And now let's predict our data. Let's see if our model is working now, okay? Now this is the actual AI part, right? Well, but now in the end, you guys know that now everything is just math. So it doesn't sound so exciting now, I know. Okay, so let's get our testing data here. df.test. It's going to be the same way, so drop all the columns. The charge column, I mean. And the y test is just essentially going to be on the df.test charge. And now we're going to create a variable to store all of our predictions. So we're going to call it y prediction, like this. And we're going to access our model here that we just trained and write model dot predict. Simple, right? And now we want to pass here the features, right? So it's just the X test, okay? Does this make sense, guys? You guys have any questions? Okay. So again, this is the features. Make predictions. And now we can run it. And here, we don't have to actually write anything, okay? This is all just for visualization purposes. Most of it, I kind of just use ChatGPT to get this. Yes? Oh yeah, of course. This? Yeah, of course. But yeah. And again, guys, nowadays, you guys have to actually use everything you can to make sure you have access to everything and all kinds of power for the knowledge and everything. You good? Oh, awesome. And now, once we did our predictions here, and again, on this part here, you don't have to worry too much about it. It's just like plotting the graph and everything with colors and title and everything. And again, this here is the R2 score, remember? Now, we are here to test our y-test and our prediction. And if we get something close to 1, then that means that our model is actually performing pretty well. Let me show you. Let's run it. Awesome. Okay, so what is this actually saying here? Okay, so we have here our predictions and our actual price. So for example, if the actual price here was 0.4, we predict something really close to it. You guys can see it? And here, if it was like 0.3 or something, then it was not so well, but it's okay. But you guys can see the idea that the more like they fit into this line, then the more accurate it is. So that's the idea of calculating the R2 score here. And this is our score here, 0.98, which is really, really good, okay? And the mean squared error is another metric that we can use to analyze the error in our prediction, okay? Isn't this pretty cool? This was actually one of the first projects that I had in my resume when I was applying for internships in the last year. Oops, sorry. Do you guys have any questions on this? Yes?
I'm getting an error in one of the lines in section 2.
In the data part?
Yeah, but it's for one of the lines that we didn't write, but they were already there.
Is it
It's the one that's defining Q1.
Q1?
That says Q1 charge. That one, I'm getting an error for that one.
Mm.
Can I go and show you?
Oh yeah, sure, yeah, sure. It's weird. Did you run this first part?
The first one.
Just to make sure, yeah.
So I run this, the first one,
Mm-hmm.
and then when I run this one,
Charge. Wait, what? Wait,
I don't know if it has to do with the data, this.
no, but it should have the data. Let me see. Let me go over here again. DF charge.
Yeah, that one I didn't change because it was already there. So I don't know why I'm getting an error there.
Well, yeah, this is actually so weird. Quanta, yeah, doesn't matter, right? I mean, this. This is the data, right?
Yeah, that's the data that I downloaded from GitHub. I downloaded it last week.
Okay, it was from here, right?
Yeah, from there. I
Chart.
downloaded it from there.
Wow, it's actually pretty weird. Let's remove it. Let's see if it runs here. Well, we don't have. Hold up. Let's run without the outliers.
Okay.
Let's see if it works. Retype. For some reason, it's not reading this. Hold up. Let me just do a break here so we can. Okay, guys, so now that we just finished this part, I'm gonna do a little break now, okay, like a 5 to 10 minutes break, okay? And yeah, so then we can continue with the rest of the workshop, okay? Hold on. Hey, can I try to do that again? I want to see the error message. Maybe.
Should I remove the comments from here?
Yeah. Put it all back again. Oh, but it might uncomment the.
Some things, yeah.
Like
How do you uncomment it? Like,
uh,
then
it
what's
was
the command for?
command
This?
yeah, but just make sure. Okay.
Oh,
Oh,
it's
it's,
good, okay.
yeah, okay, it's
So
good.
try to run it now?
Yeah,
Let me run this first part again.
right. Click again. Just yeah.
There you go.
Oh my god.
Okay, so I tried doing this.
Let me
like,
see.
explain error, so the
Oh,
AI
the-
can explain it.
I didn't know you
Yeah,
had
the
that.
Gemini, and he was saying that the charge column is not found in the data frame, but it should be there.
Hold up. Go back. Let me just do something now.
Yeah.
Let's do df dot head to get like the columns and
Okay.
see what's happening. Oh my
it's something
god, it's another it's another data. Wait.
So did I download the wrong one? Yeah, I think I did.
Oh my god.
Let me see, because I downloaded I think last time.
Wait, did I put the wrong data?
It might be mine. Let me replace it.
Okay.
That might be the problem.
Uh,
Can I use that? Delete it.
yeah, delete that.
Okay.
Wow, that's so crazy.
That was something that we did. I think in the first one, maybe the one that I had.
Wait,
Hold on.
Wait, but I think I have that data in my computer, but I don't think I actually, did I put this data there?
Let me run it now. Yeah, it's good now.
Wow, oh my
I
god.
didn't realize. That was
No,
something that we did, I think, like in the first or second workshop.
mm-hmm.
That we worked with.
Maybe it was some data that, oh,
Thank you.
but I'm so glad that it's working. Oh, okay, perfect.
Thanks.
Absolutely, man. Yes.
I've
Wow,
seen,
what's happening?
have everything correct, but when I try to run it,
Mm-hmm.
It doesn't convert the data to a scaled version. Right here. Yeah, you know, it's.
Actually, it's because you're printing here the old data. It should be like the df string
Oh, so df's
underscore train
train.
dot head,
Oh,
and then now you
I have
should
to
see.
run it.
Yeah, have to. Let's see if that one. Mm-hmm.
Oh, now it
Oh,
works.
nice.
Thank you.
No, of course not. 20 minutes. Yeah. I'm not gonna do my. Sure. Okay.
3 días a la semana. Tengo que ir ayer y 4. Sí, también. No, eso no se pasa nada. Solamente con teoría, siempre bueno, siempre por fantasy. ¿Hay fantasy? Sí, como que agarra al jugador, exacto. Es como por el mismo de yo no lo traté, pero sabes que yo con Octavio tocaba 4. Yo también. Nosotros tocamos 4 puntos en el colegio. Demasiado raro. Muy raro. Sí. Sí, él vive en Georgia, creo, en Atlanta. Octavio. Y el hermano también.
Okay. Okay. I think I'm just gonna wait maybe just 1 more minute because I see some people are not back. So wait a little bit more.
Yo hice la prueba de San Vicente pero como que yo era menor de lo que podía, no sé si me sonaba ya todo. Dame que Cordero. De fútbol, creo, ¿no? Pero hace tiempo, creo. No, sí, no hace. Pero sí, yo conozco al hermano de Magui, que le dio la transición. Mañana siempre que yo estaba viendo un periódico, Pablo también fue que yo soy muy tres. Me pregunté ninguno, entonces estaba viendo algo así, como Juan Pablo, creo que está bien. Y Juan Pablo igual creo que también. No, creo que está en grado más o grado, sí, pero es un corto. Pero es bien. La presentación muy bien. Nosotros pensábamos que había que presentar el salón, pero muy bien.
Okay. Oof. I know we're still waiting for some people, but I'm just afraid that we might not have a lot of time now. Oh, but is that your backpack? Oh, oh my God. Oh, man, I thought it was somebody else. I wasn't waiting for. Oh my God. Okay, so let's get started with probably one of the most interesting topics in the entire world, which is neural networks, okay? So, what exactly is a neural network? Okay, so this could be this could feel more of a little bit of advanced topic or something, but I'm here just to cover like a very introduction to this whole topic. Okay, in the Explore Hub, I also put some other materials that you guys can access. They cover a lot of more stuff into this topic, and I really, really recommend you take a look at it. Okay, I'll show you guys later. But for now, what is a neural network? Okay, so a neural network is basically a computer science topic, a part of computer science, where we're literally trying to build our brains the way that our brain works into computers. So for that, to be able to understand what a neural network is, we need to understand a little bit about our brains, which could sound crazy, right? But what do our brains have? We have what's called a neuron, right? And these neurons, they literally they make connections with other neurons so that we can make our thoughts, which is basically the output, okay? And it's the exact same thing that we are doing here. We are literally trying to mimic our brain into a mathematical way. And how do we do that? Okay. The first thing, as always, that we're gonna need to do is an input layer like this, which could be a vector. And what exactly is the input layer? It's just the features, okay? These are basically all the features that they're in the initial input that we want to get started with the neural network, okay? But the real magic happens when we have what's called a hidden layer or hidden layers. What exactly are those? Okay, before I get into that, I first need to cover just some basic concepts like, what is a neuron? So a neuron, at the end of the day, is just a number, okay? So each of these dots here that you guys see, they're all numbers, okay? And they hold a number, okay? All of it, they hold a number, okay? Now, we have also layer. A layer is this vector right here, like this, okay? Or a matrix, okay? And another important concept to understand is what's called the weight and bias. Because what is happening here? So we have the features, right? But so far, it's not really useful. There's nothing we can do with it. So if you want to make some kind of prediction or some kind of classification here in the end, we need to make sure that based on the features that we input here, they can make sense in the end, okay? And for that, we have these hidden layers, okay? And what they are basically doing is they are adding more complexity to our data. What do I mean by that? Is by adding these layers and these neurons right here, we can actually try to process our data to see if we can find patterns, okay? Things that make up our features that will eventually be used to do some prediction right here in the end, okay? And how do we do that? You guys can see that all of these features, they are connected to each of the neurons, right? This way, like this, and the feature like this, and this feature like this as well. Well, if we just pass like this number to the next neuron, well, it's not gonna do much. It's just gonna be the same number, right? But the magic that happens